Hello learners. In this entire series of lectures, we'll take up this module 3, which is specially on hardened concrete, and we'll try to understand them one by one. So the first we'll start with factors influencing the strength of hardened concrete. Then we'll try to see what is water cement ratio. We'll see what is gel space ratio, the maturity concept. Then we have a very interesting one, that is the testing of hardened concrete. That is a compressive test. We have a flexural test. We have a split tensile strength. Then we'll try to understand what is creep, how the what are the different factors which affects the creep, what is shrinkage of concrete, what is plastic shrinkage, what is trank shrinkage, when it happens, what are the factors influencing them. Then we'll try to see what is durability, right? And also other than that, we need to understand what is sulfate attack, we have to understand what is chloride attack. Then and there are other things like carbonation, freezing and thawing, corrosion and other things. And the interesting part is about the non-destructive testing like penetration and pull-out test. Then we have rebound hammer test, ultrasonic pulse velocity, core extractions and other things. So we'll be taking them one by one. So in this lecture, we'll try to see what is hardened concrete, what are the properties of a hardened concrete, and we'll see them one by one. Yeah, now coming to the properties of hardened concrete. So the final stage of the concrete making process results in the hardened concrete, because so far what we had seen, it was about the fresh concrete, right? What is the care that we need to take on the fresh concrete and all. So once you place the concrete is slowly going to gain the strength, and once it gains the strength, it becomes a hardened concrete for me. So in this stage, the surface of the concrete cannot be worked by applying the pressure. So the following are the important properties of the hardened concrete. The first is about the strength. So how do you determine the strength of the concrete? So we have different tests, like I mentioned. We have a compressive test, where we'll try to see what is the compressive strength of my concrete, because we know that the concrete is strong in compression and it is weak in tension. Then we have a tensile strength. So we'll try to see how the tensile strength has to be done. And we'll also try to see what is the flexural strength of my concrete, how those experiments have to be carried out, and also the bond strength. The next is about the durability, right? So durability is also an important factor. If you have only strength in your concrete, that is not going to help you. Along with the strength, we need to have the durability. That means how long my concrete structure can last, right? So that is called as durability. For example, now see here, whenever we do the construction and all, we try to give this cover blocks, right? So these are the cover block for the column, which we give 40 mm, and this is a cover block for the beam, which we usually keep 25 mm. So what it's actually doing, so it is not allowing my rebar, this is the reinforcement bar, to get exposed to the atmosphere. So as a result of that, what will happen, there won't be any problem in my rebar. Just in case if you're not giving the cover block, and if this rebar is exposed once you pour the concrete, then it will come in contact with the air, and as a result of that, what is going to happen, there will be corrosion, and this corrosion will make my concrete, the strength of my concrete structure, to come down. That means the durability of my concrete is going to come down, right? So this is the another property of a hardened concrete. Then the next one what we have is the impermeability. That is how much my concrete is able, I mean how strong it is able to resist the ingress of the water, which is called as impermeability. Then we have important other factors like the dimensional stability, that is about the elasticity. Then we have shrinkage, then we have creep, and the thermal expansion. So these are the shrinkage cracks what we can see once you place the concrete. And if the temperature, if the surrounding temperature is very high, the chances of water getting evaporated is more. And if the chances of water getting evaporated is more, then what is going to happen, there will be cracks. That means a concrete will try to shrink. As a result of that, the cracks are going to form there. So these are the shrinkage cracks what we get. So this all comes under the dimensional stability. We need to understand all these things one by one, right? Yeah. So so far what we had seen, what is, like if I go back, so we had seen all the fresh properties of my concrete, right? So how the concrete has to be prepared, how you have to place them. We have understood how the batching of a concrete should happen, right? And how, what are different ways of preparing the concrete and all. And also after that, finally we saw that how the curing has to be done. Yeah, give me a minute. Yeah, how the curing has to be done, and how you're going to place the concrete with the help of these machineries, and compaction, finishing, everything is done. So all this we were doing on the fresh concrete. So once the fresh concrete is done, next we need to understand about the hardened concrete, which we are actually trying to understand now. So to put it in a better way, we'll try to understand this way. So it's a newborn baby what we have here, right? So imagine this is like a new, it's a newborn, let us say this is a concrete what you prepared, it's a freshly prepared concrete, right? So just now the concrete is placed. So from here the maturity of a concrete is going to start. How it's going to start? So slowly what is going to happen, you'll try to cover that, right? So this is from, let us say it is from, if you don't cover this, if you don't cover the baby, what will happen? So you'll be having a surrounding temperature, the heat and all, right? So it is something related to durability. So if the durability is good, what is going to happen? This baby will not face any problem. It's something like the cover block with what we try to give to the uh, structural elements. So then slowly my concrete, after few days, it's going to gain the strength. Like initially, as soon as the baby is born, it cannot take the strength on it, right? It requires some time to take the strength. So slowly after some time, it's going to take your help, and it slowly it starts to move on its own. In the same way, you see it here. So once, see, the main intention of putting my concrete is it has to take the strength, right? Ultimately it has to gain the strength, and it has to take the load which comes over that. So let us say this is it let us say this is a 7-day concrete what I have. So in the 7 day, what, like let us say today I'm pouring the concrete. After 7 days it's going to gain certain strength on it, right? So after 7 days it's going to take little strength on that. And after 7 days, the next, usually what we try to look is after the 14 days. So 14 days it, the concrete will try to grow a bit, right? And then it's able to take more load compared to the 7 days. The 14 days load carrying capacity of a concrete is going to increase. And finally the concrete has to gain more load for which it has been intended for, and that load we usually get at the end of 28 days. So it has been found through experiments and all that concrete is going to gain almost 95 to 97 percentage of the load, right? Let us say if I'm preparing a M20 grade of concrete, so this 20 is the characteristics compressive strength of the concrete. Let us say 20 Newton per mm square. This much strength it has to gain. So this much strength of the concrete will be gained at the end of 28 days. So finally, the concrete is able to take the load. I mean, it's able to gain the strength for which it has been intended for, and it's able to resist more and more force, right? Let us say you're putting up a G+5 building, a ground floor, first floor, second floor, third floor, and fifth floor, right? So once it has been put up, it has to be in a position to take the load of all the floors and all, right? So that is what I'm trying to tell you. So it has to take all the load coming on it, right? So with this help, we'll try to understand this entire series of lectures, what are the different properties of the hardened concrete. As soon as the baby tries to gain the strength and all, there are a lot of the things that we need to understand, like we saw there about the dimensional properties, the shrinkage properties, the creep, right? All those things we need to understand. Yeah. So the final thing what we have is the concrete must be strong enough to support its own weight plus the weight of whatever will go on the top of it, as we have seen it here, right? And then it could be a building, or it can be any tracks or people walking on it, whatever it may be. It has to take the load for which it has been put up for. Without the enough strength, the concrete is useless to us, right? If the concrete is not able to gain the strength, then there is no point in putting the concrete. So that's it. This makes the strength the most important property of the hardened concrete, and it gives the overall idea of its quality. The strength of the concrete is can be measured with the help of direct compression. We can make use of tension, bond, abrasion are the commonly used properties for its structural use. So these are different tests what we try to do. So this is a compressive test what we do. So we prepare a cube out of concrete, and then we try to apply a compressive force, that is from here with this is called as compressive testing machine, or you can make use of universal testing machine also. We are putting a compressive force C and C, then we'll try to see how the cracks are going to be generated, what is the capacity of this cube. So this is a compressive testing machine, I mean compressive testing machine, and this is how we try to do the compressive test of a concrete. And we'll try to understand this in more detail where as we proceed with the lectures. Then this is a flexural test of a concrete, because if you try to put more force, it's going to fail, right? And we know that the concrete is strong in compression and it is weak in tension. So to put it in a better way, let us say this is the beam what I've taken, and this portion will be my neutral axis. That means here the stresses will be zero. Neither there will be compression nor there will be tension, but above this there will be compression, and above this there will be tension. And as I mentioned, my concrete is always strong in compression. If I say concrete, okay, it is strong in compression, right? But if I put a tension force on this concrete, then my concrete is very weak in tension. As a result of that, you can see the cracks have started to develop from here, right? It's the crack is not from the top, the crack is started from the bottom. The reason is that my concrete is weak in tension, and below the neutral axis, this entire portion what I have, this is in tension. That is the reason you can see the crack has started from here, and that means this will this implies that my concrete is not strong enough to take the tension coming on it. Then we try to put the reinforcement into this. We already understood that is the reason we go with RCC, right? So then we try to put the reinforcement into this concrete, and practically you might have seen the rebar being put into all the concrete so that it is able to take the tension force coming on it. So we have to do this test also, that is a flexural tensile test. And the last one is a split tensile test, or actually if you put it other way around it becomes a split tensile test. Otherwise if you put it vertically then again it becomes a compressive test what we do. But especially in India we always do the compressive test on the cube. But if you go to United States and all, they do the testing on the cylinder and they don't use the cube. And always the test what you do on the cube gives you a better result compared to the cube. And we'll try to see what is the reason behind that. Why is that in India we do cube test and in other countries, in US, they do cylinder test, how it has to be done. All those things we'll try to see in the upcoming lectures. So it was just a kind of introduction, I would say. So we so that we get a better idea what are the different properties of the concrete, hardened concrete, and how it has to be understood. Yeah. So in the next lecture we'll try to take what are the factors affecting the hardened properties, and we'll try to understand them one by one. So we'll see you back in the next lecture. Thank you.